Have you noticed the shapes can turn into sounds? What are you doing here? Okay, now it's better. Yeah, that's where you should be. I recently saw a video about turning the shapes into sounds, and I'm gonna try it myself to see the challenges ahead. And I'm gonna rate how hard it is by 1 to 10, so stick with me till the end. Here's the flowchart so you can see what's going on in this video. And for the first step, I'm gonna write a simple shape. Here's our circle as a simple shape. It has a position and a radius. After that, we need a rider. Here's the rider. As you can see, it has a position and an angle. What I'm gonna do is I wanna add a tiny amount to the rider's angle, and after that, recalculate the rider's position based on this formula. You can already see how precise it moves by changing the angle. And this is what happens when we do it in every frame. Mwah, super smooth. Okay, first step is done. Let's go and make a sound out of this rider. First, let me show you how to work with sounds in P5.js. On the first step, you have to make sure that you include the sound library because it's completely different from the main one. Here's the syntax. You make an oscillator, you set the frequency and amplitude, and whenever you want, you can start and stop the sound by these two functions. Easy, right? I'm gonna use the Y value of my rider as the frequency of my oscillator. Let's see how it sounds like. Actually, the sound was not that interesting for me because if you look at the range of the Y value of my rider, you can see that they're pretty low. I want the range to be, for example, from 200 to 2000. And how can we do that without changing the radius of the circle? That's where we use the map function. The map function is used when we want to convert a value between a range into a value between another range. For example, 40 between 0 and 50 will be 80 between 0 and 100. And here's the syntax. So the final code will look like this. And here's the result. Next step is done. Let's go and make a custom shape. As you may realize, this rider is specifically for the circle, so we can't use it on any other shape like a square. So to have a universal rider, we have to make our own shapes, adjusting every point by our hands. Oh my god. Here's how the shape works. It has a main position and an array of points which are coordinated relative to that position.
Mission accomplished.
Let's go and write that shape. This time our rider has a different logic. It has to follow the points of our shape one by one. And if you've seen my path following video, you probably know that making a point follow another one is pretty simple. So this time our rider has a position and a target which is going to follow. And every time it reaches a target, it goes to the next one. Next step is done. Let's go and make the sound out of it. And making sound out of this rider is just the same as the previous one. Let's see how the square sounds like. The sound is done. Let's go and show it on a plot. I made this plot with some lines and arrows. Let's see what I can do with it. Take a look at this. This is my shape and this is my plot. As you can see, my rider has a relative position compared to the shape position. And if I simulate that same position from the center of my plot, I'll get to this position. And you can see how easily we can simulate the movement of my rider on the plot. And now let's generate new points on the position of my plot point, which looks like this. And the last trick is to shift all of the generated points to the right every frame. I guess the only problem is we don't have to simulate the X position, we just need the Y position, and X position can be fixed. Just like this. And the difficulty is 4. Let me know what you think about it in the comments down below. I guess we're pretty much done. I'm gonna show the results that I could get out of it at the end of this video. Make sure to subscribe so you don't miss the other algorithm adventures. And as always, keep yourself hydrated. Oh, yeah. Peace. Bye.